So resource management. Let's look at an example project and let's go through the process of identifying what resources we need, allocating the resources, finding the issues and resolving the problems. So basically, whenever you're doing a resource analysis problem, first thing you need to do is have a dependency chart of the tasks and then make a Gantt chart showing the durations, allocate the resources on the Gantt bars, draw a histogram or a resource graph or a resource profile that shows you how many resources you need over time, and then smooth that profile to make it as smooth as possible. So remember, the dependency chart just shows the dependencies between the activities. It has to have a start task and a finish task. There are no loops, there are no dangles. All of the tasks are connected with arrows. There's no lead or lag in this dependency chart. And the dependency chart, unsurprisingly, is excellent at showing the dependencies, but does not show the durations. Now, a Gantt chart is a layout over time showing the length of time of the tasks. Now, in this Gantt chart, I'm showing the critical activities in red, the critical path. The non-critical, sometimes called the normal activities, non-critical, are in the lighter blue color. And the Gantt chart is excellent at showing the durations, the comparative durations of the tasks in the project, but not good at showing the dependencies. I'm not showing the dependencies here because it's quite clear. When I start to add the dependencies, the diagram gets complicated very quickly. So use a dependency chart to discuss project task dependencies. Use a Gantt chart for what it's good at, which is showing the durations of the tasks. Now, in this slide, all I've done is I've taken the critical path activities, tasks A, C, F, J, K, and L, and in the Gantt chart, I've put them end to end on the same line. The other activities, the non-critical activities like B and C, you can still see the dependencies. When A is finished, I can do B and C and D. But I'm showing these as normal tasks, white tasks. But I'm showing the float, the amount of slack that is available before we feed back into the next task or the critical path. Now here I'm allocating the resources. On this project, there's only one resource I'm interested in. Let's call them engineers. And so I'm putting a number underneath the task. So for instance, task B needs 1 engineer, task C needs 6 engineers, task D needs 1 engineer. And task A and L have got no resources on them. Maybe they're done by the management staff or a different resource. You'd have to prepare a resource graph for each type of resource separately. In this exercise, I'm just interested in engineers. So at the top here, I'm showing that same Gantt chart with the resource allocations. What I need to do is create a histogram or a profile or a resource graph. So I'm going to count how many engineers I need each day of the project. On day 1, no engineers. On day 2, there's 1 engineer on task B, 6 on task C, and 1 on D. On day 2, I need 8 engineers. And I work my way through the project, counting up how many engineers I need to draw this resource graph or resource profile. Now here I'm showing the finished graph, and I'm showing my problem in red. I've only got 9 engineers available. So anything above 9 engineers is going to give me a resourcing problem. Perhaps I've got another resource problem in this project, and that is that I'm not using 9 engineers for the end of the project. I'm only using 2 engineers for many days at the end of the project. That is equally a resource problem. So how am I going to solve this problem about not having enough engineers in those red areas on those days where it's red? Now, let me give you the wrong answers. The answer to this problem is not to cancel the project. Haven't got enough resources, cancel the project. That would be the wrong answer. Another wrong answer would be to say, no, not enough resources, I need more than 9 engineers, let's get some contractors in. That's not the right answer. That could be very expensive. It's money going out of the organisation. Another wrong answer, asking the staff to work overtime or cancelling their holidays during these red overloaded periods. And now actually that's not going to help in this case because we've nearly got a requirement for twice the number of engineers that I have. So 9 engineers is shown in blue. I think I peak at 16 engineers required. I'm not going to solve that sort of problem by working a few extra hours in the evening and at weekends. Cancelling another project is the wrong answer. That might provide resources for these peak periods, but it will demotivate that project team. Why was their project cancelled? It will demotivate my project team. You know, aren't we good enough to complete this ourselves? It's not required because the correct answer to this problem is to use the float. Delay those non-critical activities into the periods where we don't have a resource problem. So in this example, if I delay tasks G and tasks I using the float period or the slack period, we can actually do this project without any overtime, without any contractors, without cancelling any other projects. Now, we want this resource graph or resource profile to be as smooth as possible. This is why it's called resource smoothing. Can you imagine me going to management with this resource profile and say, I need 9 engineers for my project from day 1 to the end? It's a fairly flat profile. Compare that with the previous profile, where I might say, well, I need to start with 6 engineers, then I want to peak at 16 engineers, then I can drop down to, say, 7 engineers, then I need 15 engineers, then I can release them back. The problem is that you might get allocated the engineers, but when you release them, they might then not be available when you want them. A smooth resource profile says I can keep the engineers allocated to me busy for the life of the project. So, resource management analysis, an example. We've worked out what resources are available, allocated it to the Gantt chart. We've drawn a resource profile to show what resources we need. And then we've said, well, we've only got 9 available, so I have a problem. And then we've looked at resolving the problem by looking at the project plan. In this example, I didn't change the dependencies. I didn't add lead time or lag time. I didn't get more resources. I used the float. I delayed the non-critical tasks, and I achieved this project with 9 resources within the project timeframe.